It's going to be that kind of a day. Good morning, everyone. Afternoon, whenever you happen to be watching this. It's going to be that kind of a day today. I'm feeling it down in my bones. In my bones. All right. Today is the day we're going to be talking about measurement of angles. Now, you've been measuring angles for quite some time now, but you may not have measured them quite like this before. An angle is said to be in standard position if its vertex is right here at the origin. And when you see that word origin, we're talking about the origin of the graph again? Yeah, origin 0, 0. We're measuring these angles on a graph. What? Its initial side is on the positive x-axis. Remember we talked about our unit circle a little while ago? The initial side was over on that x-axis. Like this guy right here, we call this guy the initial side. That means this is the origin. It's crazy. And then a counterclockwise rotation represents a positive angle. So that's going this way. Woo, positive. A negative or a clockwise rotation represents a negative angle. So if you go to the clockwise direction, like a clock runs, we represent a negative angle. And if you really think about that, up is positive all up in here, down is negative all down in here. So it's pretty easy to remember that way. At least I think so. So there's a couple things I want to point out here. In Greek letters, theta, beta, or alpha, or capital letters, or capital letters are used to denote angles. The amount of rotation can be measured in degrees or in radians. All right, so you got the Greek letters theta, beta, and alpha, or capital letters. Those are going to tell you what your angles are. All right. So let's talk about radian measure. Now you already know what a radian is because we talked about it in class. It's the measure. Now this is technically the formal definition of a radian. It's the measure of an angle AOB. It's the number of radius units in the arc length. Remember, it's how many times will the radius fit in this little arc length right here. So what we do is divide the arc length by the radius. All right. So whatever S is, we divide that by your radius R. It's very simple. If the think about radian is how many times the radius fits out here. So if this is our arc, then we just want to know how many times will the radius fit inside of that arc. So let's actually come up with some of these and try and do them here. Number one, to start off with, they're coming up with theta. We have an arc length of S and a radius of 2. So very simple. Theta is going to be 5/2. Now you can write it as a decimal, but remember, we don't start with decimals unless we don't end with decimals unless I give you a decimal. All right. So again, note that if an angle is in radians, it has no units, right? If an angle is in radians, it has no units. It's just 5/2 or 2.5. So number two, we've got an arc length of R and a radius of R. So arc length over radius is R over R, which is 1. So 1 radian is the measure of the central angle whose arc length has a length of R. So if you have a length of R, if you lay your radius out here one time, that's 1 radian. That's what we talked about before. So let's talk about going between them. Converting between degrees and radians. Since theta is S over R, and 1 revolution, right, 1 revolution is 360 degrees, what we can do here is take our radian measure, which we said was your circumference, right, the distance around the circle, circumference, and divide that by R. Well, what is your circumference? Your formula for circumference is 2 pi r, and you're dividing that by r. So really think about this. Think about what we said in class today and Friday. We said that 360 degrees is 2 pi, right? So that tells us that divided by 2, that tells us that pi is 180 degrees, right? So what that tells us as far as formulas go, to go from degrees to radians, you're going to take your number of degrees and you are going to multiply by pi, ding, and divide by 180. To go from radians to degrees, you do the exact opposite. You start with x radians, multiply by 180, and divide by pi. So degrees to radians, radians to degrees. Let's actually get into some of these here. Convert negative 225 degrees to radians. So I'm going to say negative 225 times pi divided by 180. All right. When you simplify this, you get negative 45 pi over 36. These can simplify to negative 45 and 36, both those being divisible there, which is negative 5 pi over 4. Convert 50 degrees to radians. 50 times pi over 180. Zeros can go away, and you got 5 pi over 18. Very simple, just using our formulas here. Convert negative pi over 3. So when you get to these, you have negative pi over 3 times 180 over pi. Easy to remember this one because you're looking for your pi's to cancel out, right? I'm looking for pi to cancel. So what I've got then is 180 over 3, which is divisible by 1 into 60. So that's 60 degrees. Negative 60, excuse me, because it's a negative pi over 3. And then 3 pi over 4 times 180 over pi. Again, looking for those pi's to cancel out. Alright, so you've got 4 and 180. That'll bust up into 45 degrees. So what you're left with is 3 times 45. Remember, when you multiply fractions, multiply across the top and across the bottom. There's nothing on the bottom anymore because we simplified it. And there we have it, converting. Alright? Let's go on here. If the terminal side, meaning where it stops, remember the terminal side is where it stops. That's what's listed right here. The terminal side is where it stops. If the terminal side lies along an axis, then the angle is called the quadrantal angle. So you got 0 degrees here, 90 degrees up here, 180, 270, oops, and 360. Remember that those are called your quadrantal angles. So if I ask you for a quadrantal angle, that's what I'm expecting. Radians is 0. We talked about this the other day. There's 2 pi total. Divide that in half, you're at pi. Divide that in half, you're at pi over 2. And halfway between pi and 2 pi, you've got 3 pi over 2. So those are your quadrantals. So we're going to do a couple of sketches here real quick. It says sketch 120 degree angle, sketch a negative 45 degree angle. I'm going to draw an axis real quick. It's just a sketch. It doesn't have to be perfect. 120. So here's 90. Here's 180. It means 120 is going to be up in here, right? Always show which direction you're rotating with this little circular arrow thing. And then label your angle. Always show the direction of your rotation. So a negative 45 degree, now we're going in a clockwise rotation because it's negative. So here's negative 90, negative 180, negative 270, negative 360, because we're going this way. So if this is 0, this is negative 90, that means negative 45 is going to be between 0 and 90. Negative 90, excuse me. Now sketching in radians is a little bit trickier, but not really. If you think about your quadrantals here, you've got 5 pi over 4 radians. Well, here's 0, here's 1, and here's 2. 5 over 4 is bigger than 1, right? But is it bigger than 1 1/2? In other words, is it bigger than 3 halves? 3 halves would be 6 over 4. So 5 pi over 4 is going to be somewhere in between 1 and 3 halves. Right here. Again, 5 over 4 is bigger than 1, so it's going to be down here. And what about the negative side of that? Negative 3 pi over 2. Negative 3 pi over 2. Wait, 3 pi over 2 was this quadrantal angle, so we went to here with 3 pi over 2. So if now I'm going in a negative direction, it'll be negative 1 pi over 2, negative 2 pi over 2, which is 1, negative 3 pi over 2. And that's a quadrantal angle, right? It lands on one of your axes. That's a quadrantal angle. So there's your angle. And it'll go up forever like that. So hopefully this is making a little bit of sense here. You're just going through and matching up which quadrant this is going to be in. Remember that your quadrants are starting up here with 1, 2, 3, and 4. And that's going to be what the last part of this is actually about here. It says, give the quadrant for each angle. Now for this part here, we're actually going to do this in class. So I'm going to go ahead and stop where we're at, and we'll pick up with some of the homework. All right, so we'll get to that a little bit later in class. There are a few of these I'm going to do just to make sure that you're actually understanding, that you are fully aware of what's going on here. We have your homework. If you would bust that out for me real quick. Convert each degree measure to radians. Leave in terms of pi. Convert each radian measure to degrees. And you're in degrees. Sketch each angle in standard position. On the back. And then give the quadrant for each position. Now I'm just going to do some of these very, very quickly. These aren't going to take very much time at all, if any. Very quickly here. Convert each degree to radians. So I'm going to take 315. Right? Multiply by pi over 180. So 315 divided by 180. Alright, so that will be 7 pi over 4. Oh wow, you couldn't even see that, I'm sorry. 315 times pi over 180 is 7 pi over 4. I'm going to try and get this in the 15-minute mark so we don't have to post 2 videos. Yay! Negative pi over 2 times 180 over pi. We all know what's going to happen here. This is going to be negative 90. Right? Pause it if you need to pause it. Sketch the angle in standard position. Where are we at? We're at 14 minutes, 30 seconds. Sketch the angle in standard position. Let's give me a weird one. 5 pi over 6, 33. 5 pi over 6 is slightly smaller than 1, but it's bigger than a half. So we'll call it here. And then give the quadrants. We're going to do that in class. We made it in the 15-minute mark with 9 seconds to go. Woo! Bring these to class. We'll cover them then.